Today I'm going to be doing number 11, which is a person doing a chin-up weighs 700 newtons exclusive of the arms. During the first 25 centimeters of the lift, each arm exerts an upward force of 355 newtons on the torso. If the upward movement starts from rest, what is the person's velocity at that point? So first I drew my free body diagram showing the weight of the lifter and the force exerted on the torso by each arm. To find the person's velocity when the upward movement is starting from rest, it would be really nice to know the acceleration. To find the acceleration, we are going to use Newton's second law, which states the sum of all forces is equal to the mass times the acceleration. To find the net force, we're going to be doing the force of the two arms minus the weight of the person. So we will be multiplying 355 newtons, which is the force exerted by one arm, by 2, because the lifter has two arms, and subtracting the weight. We'll then set that equal to the mass times the acceleration. Because weight is equal to mass times the acceleration due to gravity, mass is therefore equal to the weight over the acceleration due to gravity. That means that when we plug in for mass, we can just do 700 newtons, which is the weight, over 9.8 meters over second squared, which is the acceleration due to gravity. When we solve for A, which is acceleration, we end up getting 0.14 meters over second squared. Because we now have the acceleration, the easiest way to solve for this problem is to use a kinematic. First, we're going to organize all our information in this chart. We will not be using time for this problem, so I just put a 0 with a slash in it to represent that, and I put a question mark next to final velocity because that's what we're solving for. The problem gives us the displacement, which is 25 centimeters, and also the initial velocity, which is 0 because the upward movement is starting from rest. Just to remind you, we just solved for the acceleration. And so just like I just explained, the initial velocity is 0 and the acceleration is 0.14 meters over second squared, and the displacement is 25 centimeters. However, for this problem, we're going to be changing that to 0.25 meters. We can then use this kinematic, which is final velocity squared equals initial velocity squared plus 2 acceleration times displacement. Because initial velocity is 0, we can just cross that out, and we end up having 2 times 0.14 meters over second squared times 0.25 meters. When we solve for final velocity, we end up getting 0.265 meters over seconds, which is our final answer.